probably the coolest feature you can use in Excel is the Solver tool. Excel can solve for you problems. Those problems would be translated in formulas. So basically what you are looking for is the result of a formula. And you can have optimization models. So you can find, for example, the highest value or the lowest value, or you can even look for an exact value. And you would basically change some of the cells that directly or indirectly are used in the resulting formula. But now comes the most beautiful part. You can also have constraints. So you have some rules. For example, if you have number of seats in a theater, that number of seats cannot be 100.25. It should be a whole number. And then you set your own rules and you feed those rules into the solver. And Excel ultimately will find a solution for you if there is a solution. The solver is an add-in, a piece of software produced by Frontline Systems. The first thing you need to do if you've never used it, I can see it in mine under the Data tab Solver. But if you do not see it, you go to File Options, and then you go to Add-ins. And from Manage Excel Add-ins, you push Go. And be sure to actually check the Solver add-in, and then push OK. Let's go now to Data Solver, and let's see what our problem is. Our problem is this. The monthly payment, so I'm going to click it, should be exactly 1,000. Now, what is going to change would be B2, B5. So basically, we're going to change the cost of home, the down payment, the APR, and the number of years for loan. The cost of home should be between 100,000 and 300,000. So we are going to add a constraint. The cost of home is right there and should be less than or equal to 300,000. Okay, I'm going to push add, and then again the cost of home should be greater or equal to 100,000. I'm going to push add. The APR is supposed to be between 4 and 6%. So then the cell reference is the APR in B4. And should be less than 6%, so 0.06. I'm going to push add. The same APR should be greater or equal to 4%, 0.04. The down payment is supposed to be between 5 and 10,000. So let's click the down payment in B3, should be less than 10,000. Add, and the same down payment should be greater or equal to 5,000. Finally, the number of years should be between 15 and 30. So I'm going to click the number of years in B5, and that should be less than or equal to 30, and add. And again, I'm going to click the number of years, and that should be greater or equal to 15. But there is one more condition here. We do not want to have 15.5, for example. So we need to add a new condition. I'm going to click on the number of years, and I'm going to choose here integer. So that means it will be a whole number. So we are done with all the constraints. Let me go back to the solver, and you can see here everything we've done. And it's time now to actually solve the problem. So I'm going to hit solve. And you have two options. One is to keep the solver solution. So let's see what happens. It looks like the cost of home is supposed to be 137, as you see it here. The down payment should be this, the APR should be this, and the number of years for the loan is set to 17 in order to obtain the solution. The solution for getting the monthly payment to 1,000 and respecting all the constraints. So we can keep the solver solution here if we want, or we can restore the original value, and we can simply generate a report to see what the solver will look like. So let's push OK. So you see these are the original values back, but we have now an answer report, and over here it shows what was before, and that's the final value. That's what we wanted for the monthly payment, and these are the changing cells. So those are the original values, and these are the solver values, and these are the constraints. So if you notice over here that you are missing some of the constraints or that something is wrong, you can always go back to the data and go back to solver and click on the constraint you need to change and just change it. Let's see what the solver actually did. So if we take the final values over here, Control C to copy, and we go back here. So let's keep in mind the total to repay loan is 216. And now let's see the solver solution. I'm going to paste the values here, and you see the total to repay loan is only 204. Let me now undo to have the numbers back. If I go ahead in cost of home and I type 150,000 and then I generate again the report and I solve the problem, we see that the cost of home did not change much. The down payment is the same. The APR now is bigger, but the number of years for repaying the loan is less. So let's see if that makes sense. I'm going to copy this and I'm going to the home loan. And let's see the total to repay loan is 246.17. And let's now paste the new values. And it's only 240. Okay, so it looks like it's better and we pay off the loan sooner. Let's undo to have back the original values. If you go back to the scenario manager, and if you use the most likely scenario now, and you show those values here, then we can go to the solver, and we can once again solve the problem. I'm going to restore the original values. I don't want to mess up with these values here, but I would like to generate a new report. And let's push OK. And let's see the third report. So let's compare the original values and the final values. We're going back to the home loan, and I'm going to make this calculation over here. I'm going to take the down payment plus the total to repay loan. So that's basically what we're going to pay. The total to repay is how many periods we have times the monthly payment. So we have 242. And then let's see what happens with the final values of the solver. If we paste those, paste values, and we actually have 249. And now you are surprised, why are we paying more? So let me just undo to have the values back. Why do we pay more? And if you look over here, the down payment for the original values was 30,000. But for the solver is below 10,000. So why is that? Because we had the restriction for the down payment. Remember, the down payment was up to 10,000. So always makes sense to put down more money in order to pay in the end less.